Hello everyone, welcome back to my shop. Today we have a MacBook Pro M1 here on the bench. I bought this off eBay, I think, and the seller wrote that it does not turn on after liquid damage. So let's have a look, get started. So there we have it. Let's open this one up. So let's see what damage we have here. So there's some I think it's oil from where he touched it, but here we can clearly see we had severe liquid income, and ooh, that doesn't look too nice. No, that doesn't look too good. There's also something. Well, even on the dents, but they are underfilled, and this shouldn't be too much of a problem. And right into here. Okay. Oh, this doesn't look like an original battery. I think. Okay. So I'll make some notes about that. So before I get this board out, I just want to get an idea. Do I want to? I don't think so. I'm not sure. Okay, so because the original owner already had it plugged in for a long time, I think it's safe to just see what happens on the amp meter, like on the upper right. If I plug it in, okay. There goes nothing. This is the rear port, and now the front port. Okay, now we have something. And we draw 2 watts, steady 500 milliamps, and then we're resetting. So yeah. So we pretty sure we have some CD3217 issue here, and maybe even some short from the liquid damage. Yeah, let's take it apart. And the board is out. Okay. So we can see where all the liquid came in. There's liquid leftovers on the fan out. There's something here on the fan itself. Under the display connector. and this must be some CD3217. I think the rear port. Well, I have to clean this afterwards. Once we get the board to work. Oh my gosh. Look what we got here. This is a really crusty CD3217 area. We also have this one here. Looks like someone sneezed there. Okay, there's another spot here with some liquid. The ISL area is clean, at least. And then we have this mess. Oh my gosh. I'm not sure if the display has survived. And it's all over the place here. Whoa, 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 whoa. Oh my gosh. Doesn't look too nice. Yeah, we'll see if the display has survived. Okay, so the connector is okay. At least nothing seems to have went into the connection itself. It's only on the outside. So, but first, oh no, just let me try once to clean this, to get most of this crust off while it's cotton. Yeah, let me try to get this off while it's dry, because I think we can get rid of most of the crust when it's dry better. Just need to find my toothbrush. So this brush should be stiff enough to get to get us started, at least. Yeah, nice. This works really nicely. And first missing component. Now that's some crustiness. So let's have a look flexboard view from what we're dealing with here. This is a 2020 board. Okie dokie. So what are we dealing here with? We are somewhere here. This is the first place. This is the debug mux. Okay. So I have to clean this anyway. So you can tell it wants to come loose. There we go. So whatever liquid that was has eaten itself pretty good. You can see there's just a little bit of copper left from this pad. I'm sure there was some solder on that before. For removing most of the crust, I now come with Windex. Oh, okay. That was the first resistor gun. No, I took it with me once again. So, yeah, we're now missing this little resistor here, which should be this one. This would be this one, which seems to be okay. It's a zero ohm, which it still should be. So the probes together are 0.1 ohm, and this resistor Yeah, looks good. So I hit this with 450 and very low airspeed, like 10-15%, just to not have it fly away from me. Okay, need to put up the air, like 25, I think. Yeah. So this is soldered properly, and I will now attempt to clear the rest of the area. The crustiness should be mostly gone, but I want to warm it up and activate the flux and clean it with the flux, the rest. Houston, Houston, we have a problem. So here's why I prefer to use Windex instead of ISO when cleaning up liquid damage. This is ISO 100%. I can do whatever I want and it just stays there. Now I use Windex and it's gone. Always do ISO afterwards. Okay, now we have this Hiroshima area. This is the master CD3217, and I'll hit it with some Windex. And I think I have to take this CD3217 off, because there would be more nastiness under it. Yeah, you can already see that. Yeah. See, just creeped under the CD3217 all the way. Take it off. This is number 1. And this is number 2. So the number 1 is the master and the 2 is the slave, and they have to put back in their original location for them to work. boiling. Sugar, sugar. Oh, Houston, we lost the pad, I think. Did we lose this one pad? Nope. Just oxidized. Yep, should take solder again, and I'm not sure what this one is. Looking at the schematics, this one, 1V8S2, okay. So we want to have good solder on that one and not want to lose it. Now it's time to reball. Look at all this crustiness. Sugar. I think I will have to get some JVC compatible double soldering station, so I don't have to change tips every 2 minutes. That looks good. We still have some things to tackle before we can try to turn this on. So like this one. Now this mess. Oh my gosh. Okay, there's definitely, this one is missing a component. Looks like 2 caps missing. And at least 1 solder pad. Okay, but first things first. This is now looking pretty good, but I'm not sure if I ripped the component there. because I think this looks like there has been a component here and there has been a component here because of the rectanglish area on the pad. What does FlexBB say? Okay. If you click the correct window, non-populated, no stuff, stuff, no stuff, stuff, no stuff, stuff, no stuff, stuff, stuff. Okay, it's all no stuff, stuff. Every second one is populated, should be. And 1, 2, we are missing this one. Which is 0. It's a 0 ohm resistor. 2, 4, 6, 2, 4. And this one. Which of course is also 0 ohms. This used to be a test pad. Gone. And what are you? 5 volt for camera. Okay. Where can we get you? I think the easiest and best way to check if we still have a connection through some wire that must be there is to check diode mode on these two and diode mode on the rest, on what's left here. Red Pro on ground. We're not in diode mode, we're in ohms mode. And this one is 0.238. 0.238. And right on the other side, like here, we should have 0.38 on these two, here and here. This looks close enough. Phew. So I think this isn't clean but repaired. Oh, there's another one, another resistor missing. So, same procedure. Okay. Which is like this area. Yeah. We have corrosion here, which is, I sense, we have a missing component here. 10 mic, 6 volt, and we have a missing component here, which is for touch ID. So we have a missing inductor. Okay, and we have a little crustiness going on here. Worst part is the missing inductor. Okay, good, I've lifted that. Oh, Houston, we're missing a pin again. I'm missing a pad. So we're missing this pad. Oh, sorry. We're missing this pad. Okay, which goes all over the place here. So it should connect to this whole area like this, to the cap, to the inductor, and also there. Okay, yeah, that's right. What are you? We have PP3B0 Touch ID. Coming in with 3.8 volt, going out 3 volt, enabled by, okay. Now let's this side. Oh man. Of course it hit the audio section. There's still so much work to do on this one. But I like to see if we get something different now. Just to see if we achieved something. So let's keep an eye on the power meter. First one is the rear port, master port, which didn't give us anything before. We got 5 volts and like 200 amps, okay, milliamps. Okay, that's different. And the other one, the same. So I think the CD3217 area is now working, I think. Okay, so we have achieved something. I will take a break from this board because Wow, there's so much stuff, and I don't know where this leads to. As being said, I'll take a break and catch up with the top side of the board tomorrow. Okay, where are we? What's this? This looks like speaker amps. The big caps seem to be 10 microfarad, 25. And we have some resistors here, which are 0 ohms. And of course, the speaker amps themselves. Okay. Then clean it up. But first, I want to measure if we have a short there. I think we have a short on PP bus, but we'll see. Nope. No PP bus short. This is also not short. Okay. So we keep on cleaning. Oh, that works really well. So what's this area doing? Yeah, looks good. This is the 5-volt power supply. Then we have this area, which was also hit. And this is here. And this is 3V3 power supply. So we definitely need 5 volt and 3.3 volt to complete the startup, I think. So that should be it on this, at least on this side of the PCB. I don't want to burn this connector, and since we don't have a short there, and check if we have a short here. No. No short here. No short. This looks promising. So 3B3 area. Do we have a short here at the coil? No, we don't. Do I have proper ground? Yeah, I have. No short here. So, oh, there's another area here. This is backlight, okay. And this one is a no stuff. And it's also not, okay. It's not present on the PCB, but it's a no stuff, so that's no problem. While we're here, just check backlight for short. Checking backlight for short. So this is ground. And what do we have here? Nothing. So no short here. Ooh, wait. This doesn't look good. Yeah, that's backlight, high voltage, and of course when something conductive goes there, it eats away everything. Okay, so I'll stop here, because I will do now what I haven't done for a long time, actually, because this board has so much liquid damage. I will put it in the ultrasonic cleaner, because otherwise I don't see how to get rid of all the liquid, all the rest of the liquid damage. Or not the damage, but all the liquid that's still on the board and may react with the board sooner or later. I want to get rid of that.